Hi, this is the forces knowledge test, okay? Kind of the minimum amount of stuff that you need to know for the forces exam, AQA exam. Right, so question number 1, what is a general force? Right, so we'll do that one first. That is push or pull. Right, so that's pretty much what a force does. Every single force has a push or a pull, right? And there's always kind of two that are interacting together. A contact force is something that is exerted between two objects, but the key to it is they are touching. A non-contact force is exactly the same. It is exerted by two objects, but they are not touching. Oops, can't even put a G on the end. Question number 2, compare a vector and a scalar. So a scalar is a quantity, right? And so what a scalar only has, it only has magnitude, okay? And I always like to say that basically it's a number. And the good examples are length. Okay, so the length of a piece of string is 4 meters. It's literally just a number. Speed. A car is travelling at 70 meters per second. It's just a number with a unit. Temperature. Temperature is 32 degrees C. Right, again, it's a number with a unit. A vector is again a quantity. So it is a number, but it has a magnitude, and also direction. Okay, so for example, displacement. Right, so displacement is, I always call it as the crow flies. So if you're thinking that if you're going to go from home to school, what you're going to do is you're going to have go sort of all over the place, down all sorts of different roads and things like that. Displacement is how far it is in a straight line, right, cutting across all those gardens and fields and things like that. Another one is velocity. Velocity is speed with direction, right? So instead of saying I'm travelling at 70 meters per second, what you would do is you'd say I'm travelling at 70 meters per second north, south, east, west, left. And the last one, as a good example, is force. Force always has a direction. So me sitting in this room at the moment, what's happening is my force is straight down. It always has a direction. Right, add in the forces. Okay, so on this aeroplane, we've got lift, we've got thrust, we've got weight, and we've got drag. Now there's other words that could come into it, like this one here could be air resistance. This one here could be upthrust. Oh, I haven't put a T on, a little line on the thrust. Okay. Question number 4. What is a resultant force? So a resultant force is, I always like to call it almost like the answer. All right, and so what it is, it's one force as a combination of two forces acting together. All right, so what you could have is you could have a box like that, and it's got a force going in that way of 7 newtons. It's got a force going in that way of 3 newtons, right? And so the resultant force, the result of the actual question, is 7 newtons that way, 3 newtons that way. What is the actual answer? It would then be 4 newtons to the right. That is your resultant force. Question number 5, right? What is weight? Weight is a force due to gravity, and its units are newtons. Mass is how much stuff there is, how much matter actually is included in something, and that is measured in kilograms. So a good question in this is, I'm sat in this room at this moment in time and I'm, I don't know, make it up, 100 kilograms. If I go to the moon, what's my mass on the moon? It's 100 kilograms because it's exactly the same amount of matter. In this room, I might be, let's go back to red, I might be 1,000 newtons. Okay, that's my force into the floor. If I go to the moon, because the gravity changes, my force changes. And my force on the moon might be 330 newtons. Question number 6. Right, I'll do these in the same colours as on there, that'll be cool. Right, what is happening at A, B, C, D? Now, what we've got here is we've got a distance time graph. So if you see a graph like this on the forces question, right, what you need to do is you need to look at this axis first. And what it'll do then, that'll then tell you how to actually work it out. So from here to here, part A, think about what it's doing. Over time, 2 hours, what it's doing, it's travelling 30 kilometres. And because it's a straight line, it is then going at a constant speed. Okay, it's not getting any faster, it's not getting any slower, it's just going at a constant speed. The blue line. Now again, think about it. From 11 o'clock till 12 o'clock, so it takes an hour, the distance from where it started is 30 kilometres. So therefore, if it stays at 30 kilometres for an hour, it must be stationary. Green, I think my green's going to be a little bit different. This is then the same as A. Right, so because it's a straight line, because it is changing its distance, it is a constant speed, but faster than A, because it's steeper. D, right, it is again going at a constant speed. Okay, and you could do a comparison. I mean, it looks steeper than it looks steeper than A, but not as steep as C. But the key to it here is, where is it here? So at that point there, there's a pretty good chance it is back to the start, because it is now 0 kilometres from where you started from. On a distance time graph, so that graph that you then had, what you can do is you can calculate the speed. Okay, so the way to calculate the speed is the gradient of the line. Okay, now if you can't think, oh my god, how do I do the gradient? Think about the units, meters per second. So therefore, your gradient of the line is distance divided by time. Because these units here, meters per second, means meters divided by seconds. So you look at your graph, find out the distance, look at the time, and then you can work out the gradient of the line from that. Question number 8. Okay, I'm going to get to me smarty pants colours again. Right, well this is a bit stupid, isn't it? Right, because what I've done now is I've included exactly the same graphing that I had before. Got A, B, C, D, so what I could do is I could just start writing them in. Or what I really should do is I should look at the axes. And what I do this time is I look at that. And now it isn't distance, it is now velocity. So it's how fast something is going. So what you do is you need to think about from there to there, 2 hours. What it's doing is it's going from 0 meters per second up to 30 meters per second. So if it's going from 0 to 30, then what it is doing, it is accelerating. Accelerating. Okay, so it's accelerating. B, change to blue. B going across there. All right, now On the previous graph it was stationary because what it was doing, it was staying the same distance. But now it's at 30 meters per second. So if you've got an object going at 30 meters per second and it stays the same for an hour, it's now going at a constant speed. Green, same as A, it's getting faster. So therefore it is accelerating, but faster than A, okay, because it's steeper. D, so what D is, D's at 60 meters per second and it ends at 0 meters per second, so therefore it is decelerating. Decelerating. Wait a minute, still probably spelled wrong. Right, but this time we don't know where it ends up because all we know is now, at this point here now, it is stationary. Right. Question number 9. On a velocity time graph, how do we calculate the distance? So the distance is the area under the graph. On a velocity time graph, how do we calculate the acceleration? It is gradient of the line, and it is velocity divided by time. Question number 10. Right, so what we're talking about now is we're talking about terminal velocity. Okay, so terminal velocity. That is the maximum speed attained by an object falling through the air. Okay, normally the question that they talk about here is a parachute. Right, so what you got is you've got your aeroplane. Now this is an aeroplane, obviously. Okay, that doesn't look like anything like an aeroplane, it's like a strange squiggle. Right, what happens is the person jumps out and the weight due to gravity pulls him down. Then what happens is air resistance is tiny to start off with, so what happens is the person is still accelerating because the weight is then bigger. But as the air resistance increases and becomes the same, as soon as the weight due to gravity and the air resistance are the same, that person has then reached terminal velocity. And what you can do then to change your terminal velocity, you can put your arms in, right? Or you can put your arms out wider, however it may well be. Question number 11. The two things make up total stopping distance of an object is thinking distance and your braking distance. So if I'm driving along the road, what you imagine is, right, you see somebody step out, you put your foot on the brake and you stop, right? And what you do is you forget about this, right? Because if I'm driving along at 30 miles an hour, it might be quite a few meters, right? While my brain is computing that I then need to actually put my foot on the brake, okay? Then I put my foot on the brake. So the total stopping distance is a combination, or added together, the thinking and the braking distance. Question number 12. List 3 factors that affect the stopping distance. Okay, reaction times, things like alcohol. If you drink any amount of alcohol in your drive, not only are you mad, right, but in my opinion, you should have the book thrown at you, because alcohol will reduce your reaction time. Exactly the same thing for drugs. Another example could be if you're tired. If you're tired, then what happens is your reaction time is naturally going to be slower. Braking distance. I mean, there are other things with reaction time as well. It can be age. So obviously my reactions, being very, very young, would be incredibly quick, where somebody older would be a bit slower. Right? And there are other things as well, whether you're concentrating, whether you're talking, but the 3 that I've put on here, they're probably the best 3. The braking distance. Okay, this is then when you put your foot on the brake, how long it actually takes you to stop. The weather. if it's raining, if it's icy, if it's hot. Tyres and brakes. Right? There's a good reason why you have an MOT. What they do is they check your tyres and they check your brakes. To make sure your tyres aren't bald, if they're bald they've got no tread, and to make sure your brakes are working properly. And the third one could be the road surface. Okay, a road surface that has got ice on it, which is kind of a combination of the weather, or a road surface that's a bit tired and it's a bit sort of slippy potentially. Right, they're factors that affect stopping distance. Momentum. Momentum is the tendency for an object to keep moving in the same direction. Okay, so if you think about two people running along, you've got an England rugby player and you've got a year 7. The England rugby player has got much bigger momentum, so they have a much bigger desire to keep moving